Hi, I am Shahul Hamid, Professor ECE, Sales and Stock Technology. In this session, we are going to discuss problem which is related to root locus under linear control engineering. First, I will read the problem statement. A unity feedback system, control system, has an open loop transfer function g of s is equal to k divided by s into s square plus 4s plus 13 sketch root locus. So here they have given a problem, open loop transfer function. We are going to just draw root locus for the given open loop transfer function. In order to draw a root locus, we have to follow some set of some steps. In fact, okay. So we are going to discuss one by one, and finally we are going to draw the root locus using in the graph. First step is we have to find poles and zeros of open loop transfer function. When we are seeing the open loop transfer function, there is nothing in numerator. There is no polynomial in the numerator. We have only constant, and the denominator we have s into s square plus 4s plus 13. So using open loop transfer function, we can conclude that there is no zeros in this transfer function, and the highest power of the denominator is 3, so there are 3 poles are available in the transfer function. So we are going to find each and every pole. So here the denominator is equal to 0. There is s into s square plus 4s plus 13 is equal to 0. So we can say that s is equal to 0 and the other one is equal to 0. We have to find the roots of quadratic equation. This is the quadratic equation because this power is 2. We have to use a quadratic root equation formula, that is, so for example, if we are considering a x square plus bx plus c is equal to 0, we have to find root using this formula, that is x is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. Okay, now we are going to use this formula when we are seeing the equation. A value is 1, b value is 4 and c value is 13. We are simply substituting this equation. S is equal to minus 4 plus or minus square root of 4 square minus 4 into 13 divided by 2 into 1. So which is equal to minus 4 square root of 4 square is 16 minus 4 into 13 is 52 divided by 2. 2 into 1 is 2, so which is equal to minus 4 plus or minus square root of, so that is 16 minus 52 is 36 divided by 2, which is equal to minus 4 divided by 2 plus or minus j into square root of 36 is 6 and square root of minus 1 is j, so j into 6 divided by 2. So when you are dividing this equation by 2, you will get 2 plus or minus j into 3. Then we have to identify poles and zeros. So we have 3 poles. One is s is equal to 0. Another one is s is equal to minus 2 plus j3 and s is equal to minus 2 minus j3. So first one is s is equal to 0 and this pole is s is equal to 0. Center this origin, and now we have to identify s is equal to minus 2 plus j3. So minus 2 is the real part and 3 is imaginary. There is j3 is imaginary part. So this is x-axis, this is real axis, and this is imaginary axis. So in x-axis we have to take minus 2 and this is minus 2 and minus 2 and j3 positive. That is, this is j. Imaginary axis 3, so just then we have to identify the pole. So this point is P2, this is P1 and this is P2. Similarly minus 2 minus J3, so it's a mirror image, so the exactly in the third quadrant. So this is minus 3J minus 2. So these are the 3 poles. Okay, we have identified 3 poles in the graph, so real graph. Okay, then after identifying poles and poles, in this case poles, we have to check whether the real axis is a branch of root locus. For that, you have to take a test point on negative real axis. For example, I am taking a test point here, okay, here, and then we have to count how many number of poles and zeros available in right hand side of the positive real axis. Okay, real axis, in fact real axis, right hand side of the real axis. Now when we are seeing this test point, after that we have only one pole, and that number of poles and zeros on the right hand side of the test point is odd number, then that point is in root locus branch. Okay, so it's here, then the test point lies on the root locus. So we are going to take a test point, and then we are going to count now how number of poles and zeros available right hand side of the test point, and the number of zeros and ones is count is odd number, then we can conclude that the test point lies on the root locus. At the same time, if number of zeros and one count is even number, then we can say that that test point is not on the root locus branch. So this is the conclusion. For this case, if you are taking test point on any place of left hand side of the imaginary real axis, then there will be only one pole available, that is odd number. Hence we can say that the entire negative real axis is a root locus branch. So in this case, the entire negative real axis will be a root locus branch. Okay, so here, and also I want to tell you one thing, that here we have three poles. So we have three branches. We have identified one branch. Okay, one branch starting at origin and end at infinity. And also I am saying that here root locus branches start at poles and end at 0. Since it has no 0, then we can say that all the root locus branch start at poles and end at 0 at infinity. Okay, so here we have three poles, and we have to identify three root locus branches. One branch we have identified, and other branches will start from P2 and P3. For that we need to follow some more steps. Next step is angle of asymptotes we have to calculate. Angle of asymptotes can be calculated using a formula which is equal to plus or minus 180 degree into 2q plus 1 divided by n minus m. Here q is equal to 0, 1, and then it will go up to n minus m, and here n is number of poles and m is number of zeros. In this case, number of pole is 3 and number of zero is 0. So when we are substituting n minus m here, you get angles is equal to plus or minus 180 degree into 2q plus 1 divided by 3. Okay, we have to substitute the value of q for different values of q. That is, here for this case q is equal to 0, 1, 2, and n minus m, that is 3 minus 0 is equal to 0, 0, 1, 2, 3. We can go up to 3. So when q is equal to 0, the angles is equal to plus or minus 180 degree by 3, we get plus or minus 60. When q is equal to 1, angles are 1 plus or minus 180 degree into 2 plus 1, that is 2 into q is 1 plus 1, it is 3 divided by 3. So plus or minus 180 degree into 3 divided by 3 is equal to plus or minus 180 degree, because 3 cancel. When q is equal to 2, the angles are plus or minus 180 degree into 2 into 2 plus 1, that is 4 plus 1 divided by 3, which is equal to plus or minus 180 degree into 5 divided by 3, which is equal to plus or minus 300 degree, and it is equal to plus minus or plus 60 degree. When q is equal to 3, the angle is plus or minus 180 degree 2 into 3, that is 6 plus 1 divided by 3, which is equal to plus or minus 180 degree. 6 plus 1 is 7 by 3, which is equal to plus or minus 420 degree, which is equal to plus or minus 60 degree. So when you're seeing this, we have three different angles, that is plus 180 degree, plus or minus 180 degree, plus or minus 60 degree. Already we have identified one branch on negative real axis, that is plus minus 180 degree, and we have to find only two asymptotes, that is plus or minus 60 degree. So in order to identify the asymptotes, we have to determine centroid value. Centroid value can be determined using the formula sum of poles minus sum of zeros divided by n minus m. N minus m is 3. Sum of poles, we have 3 poles. One is 0, another one is minus 2 plus j3, minus 2 minus j3. When you are adding all these things, j3 will cancel, and minus 2 minus is 4. Minus 4 by 3, which is equal to minus 1.33. So 1.33 is centroid value. And now we have to identify the poles and zeros and also asymptotes. I told you that already we have identified root locus branch on negative real axis. This is the root locus branch. Now we have to identify asymptotes. We have plus or minus 60 degree, and the centroid value is 1.33 minus 1.33. So minus 1.3 is on real axis, so this is 0 and 1, and it is in between minus 1 and minus 2, and this point is centered, that is 1.33. Now we have to use protractor, and we have to identify 60 degree and draw a line, and this is one line, plus 60 degree line, this is one asymptotes, and minus 60 degree. Using protractor you have to exactly draw the asymptote minus 60 degree. Now next step is you have to find a breakaway and break-in points. For this case, in fact, we can say that directly, we can say that there is no breakaway and break-in points, okay, and because the root locus branch is not touching real axis. But anyhow, it's important to check whether breakaway and break-in point is there or not. For that, we have to take open loop transfer function, and we have to find closed loop transfer function. So closed loop transfer function, there is C of s by R of s is equal to G of s divided by 1 plus G of s into H of s is 1, okay, fine, because now unity feedback system. So you have to substitute G of s in this formula, you get this one and this one, cross multiplication, and finally we get the closed loop transfer function is k divided by s into s square plus 4s plus 13. So here simply substituting the value of g of s here, and then cross multiplying and cancelling the value, you get k divided by this one. So this is closed loop transfer function. Now we have to take the characters equation. The denominator is equal to 0, then it is called a characters equation. So s into s square plus 4s plus 13 plus k is equal to 0. Okay, now you just multiply s inside the bracket, you get s cube plus 4s square plus 13s plus k is equal to 0. Now I'm going to take k one side and others on the other side. So k is equal to minus s cube minus 4s square minus 13s. Now we are going to differentiate this equation with respect to s. So we get dk by ds is equal to, so when you are differentiating, we get minus 3s square minus 2 into 4 8s minus 13 is equal to 0. Now we are multiplying minus both sides, you get 3s square plus 8s plus 13 is equal to 0. Now we have to find the roots of the characteristic equations. The same formula which we have used to find the poles and zeros, that is minus b plus or minus square root of b square minus 4ac divided by 2a, and here a is equal to just see this, a is equal to 3, b is equal to 8, and c is equal to 13. You substitute in this formula, you get S is equal to minus 8 square root of 8 square minus 4 into 13, 13 into 3 divided by 2 into 3. So when you're solving it, you get minus 1.33 plus j 1.6. These are the two roots. Now, after identifying the roots, we have to substitute in the equation, characteristic equation, that is k is equal to s square minus s cube minus 4s square minus 13. We have to substitute the value of s. In this equation, we get k is equal to minus 1.3 plus j 1.6 cube minus 4 into minus 1.3 plus j 1.6 square minus 13 into minus 1.3 minus j 1.6. And here cube is there. So if it is, there is no cube and also s power 1, we can say that power 1, we can, by seeing this is a complex number, roots are complex number, definitely we can say that the k value is not is equal to positive and real. It's definitely it's a complex number. For one root is complex number, then another root also it will be definitely complex number. So for this root, that is s is equal to minus 1.3 minus j 1.6, also the k value is not positive and real. It's a complex number. Hence we can say that the root locus has neither breakaway or break-in point. So when the breakaway and break-in point will be there only when k value is positive and real. So for this case, the k value is, that the gain value is not positive and real, and it's a complex number. Hence we can conclude that there is no breakaway and break-in point. Now we have to find angle of departure. Here we have to draw a root locus branch. So I told you that root locus branches start at poles and end at infinity. For this case, already we have identified one branch which start from pole 1. It is on negative real axis, and other two branches start from pole 2 and pole 3. So we need to know where it's starting and in which way it's moving. For that we have to find angle of departure. So it should start and which angle it has to start. For that we have to find angle of departure. Okay. So for example, if you are taking pole 2, okay, pole 2, if you want to find the angle of departure, we have to draw vectors from all other poles from P2. So this is the P2. So we have three poles. One pole is here, P1, and another pole is here. So you have to draw a vector from P1, and this is the vector, and another one, this is the vector. Now we have to find the angle between the poles, and that is P1 and P2 and P3 and P2. So P3 and P2 we can directly say that this is perpendicular, so we can say the 90 degree, and here you have to use protractor to find the angle. Otherwise you can find angle by finding this angle, that is this angle, and you have to subtract from 180 degree minus this angle, that is theta. So this theta can be determined by tan inverse of opposite side and side, that is 3 by 2, and that is 180 degree minus this one. So we have to find the angle using a calculator. Okay, 180 degree, when you are finding it, you will get 123.7 degree. Okay, now theta 1 is 123.7 degree and theta 2 is 90 degree. Using that we can find angle of departure. Angle of departure formula is 180 degree minus theta 1 plus theta 2. So theta 1 is 123.7 and theta 2 is 90 degree. So using calculator you can find you will get minus 33.7 degree. That is angle of departure from complex pole P2. So if this is positive, then when you are seeing P2, it will be, if it is negative, then it is positive. So the angle of departure at pole 3 is plus 33.7. After that, we have to find crossing point on imaginary axis. So for that, we need to take once again the characteristic equation, that is s cube plus 4s square plus 13s plus k is equal to 0. Now we have to substitute s is equal to j omega in this equation. We get j omega cube plus 4 j omega square plus 13 j omega plus k is equal to 0. Now we have to separate imaginary and real values. That is, imaginary part is minus j omega cube and plus 13 j omega. Real part is minus 4 omega square and k. So this is imaginary part and this is real part. So first I am starting with the imaginary part. Imaginary part is omega minus omega cube plus 13 omega is equal to 0. So I am just moving 13 omega right hand side. I get minus omega cube is equal to minus 13 omega, which is equal to omega square. That is, I am just cancelling omega here. The 3 omega cube will become square. So omega square is equal to 13. So omega is equal to plus or minus square root of 13. Now square root of 13 is omega is equal to plus or minus 3.6, and this is the point at which the root locus branch crossing the imaginary axis. After finding the crossing point, we have to find the gain by substituting the value of omega in real part. Real part is minus 4 omega square plus k is equal to 0. So k is equal to, just moving 4 omega square right hand side, so k is equal to 4 omega square. I am just simply substituting the value of omega. Omega is plus or minus 3.6, whether it is positive or negative doesn't matter because we are going to square it. So 4 into 3.6 square is equal to 3.6 square is 13. So 4 into 13 is equal to 52. So that point where the root locus branch crossing imaginary axis is 52. So value of k at crossing point is 52. These are the basic things related to drawing a graph. So after finding all these parameters, we are going to draw the graph, and this is the graph. So already we have identified P1, P2, P3 and asymptotes. So dotted line, this is one asymptote and this is another asymptote, and asymptote angle is 60 degree plus 60 minus 60. Then we have to draw angle of departure. Angle of departure for P2 is 33.7. So just using a protractor, you have to find minus 33.7 line, and this is angle of departure for P1, and again so you have to find plus 33.7 line, and this is the angle of departure for P3. And already we have identified a branch, root locus branch on negative real axis, and this is the branch, and it's starting from pole P1 and end at minus infinity. Now we have to draw other two root locus branches. For that, one point is here, P2 and P3, and we need to know the crossing point at imaginary axis, and this is the imaginary axis. So we have already determined crossing point at imaginary axis, that is plus or minus j 3.6, and 3 is here, this is 1 and this is 2 and this is 3, this is 4, 3.6 is just above 3.5, and this is the point is 3.6, that is positive plus 3.6, and this is negative 3.6. Now we have to draw root locus branch starting from P1, okay, which is parallel to the angle of departure line. After that, you have to touch, it has to touch crossing point at imaginary axis. After that, it should be parallel to asymptote. So I am just starting the root locus branch, and I am slowly turning, and I am just touching 6, and I'm extending the line, and it will go which is parallel to the asymptote, and we have to assume that it's meeting 0 at infinity. Similarly, I'm starting the root locus branch at P3, which is parallel to angle of departure, my plus 33 degree. I'm just turning, and I have to touch crossing point on negative real axis minus 3.6, that is J 3.6, and after that I have to extend, and then that locus branch should be parallel to the asymptotes, and it will meet the it will meet 0 at minus infinity. So this is a way we can draw root locus for a given problem. This is one type of problem, and in subsequent lectures we can see different types of problem. Thank you for patient watch. Thank you very much.